Alright, so here's what I'm doing with the has next. Well, this was a little bit difficult, you might remember. If my stack is empty, then it means that it doesn't have any next, that I depleted everything in the stack. If it is not empty, then what I do is this. I look at the, I take the iterator from the stack, because you remember that my stack has only the iterators. I'm just peeking from the stack. That means that I'm not really completely removing it. I'm just peeking at the top of the stack. This iterator is that component. And, well, if that iterator doesn't have any next item, so I'm peeking from my stack, I took the topmost one, I removed it, and I'm asking that iterator, do you have a next item? If it does have a next item, I just say true, yes, there is. If it doesn't have a next item, then what I do, that iterator has been finished. I'm done with it. There is no next item in it. So that means that I'm here. I've completed Urfa. I sent Urfa, and now there is nothing here. So what I used to do is that I pop it out. I say finished. This one is gone. And then I return has next. So what is has next?
Itself.
So it is itself. So I say that return has next. So when I call this, so what I did is that I removed the top item because that was empty. So now I'm calling it again. So that means I'm here. So this is the one. I'm coming here and I say, okay, does it have a next? Yes, it does have a next. It does have a next. So it goes on like that. When it is completely finished, it will remove everything. Let's look at the other one. I mean, that's maybe, I don't know which one is easier to understand. But, so this is the next one. So I'm supposed to be returning a menu component with the next. All right. So with this next one, if I have a next item, of course, then I'm peeking the stack, so I'm not completely removing it. I'm getting the next one, the component. If that component is a menu type, I'm pushing that back to my stack. Brilliant idea. So if it's a menu item, so I push it, so because I will be using it. And then I'm returning the component. So because I pushed into my stack the iterator for the menu, the next time when this is called again, because it will be called, because I pushed it into the stack, when next time it is called again, I will be having menu items. So will it work? Let's see if it works. So I did this. First I'm printing the menu by just calling the menu item. Then I'm getting the iterator. You see here, let's zoom in. So I am getting from my menu, this is, you remember this was my main menu. I'm telling it to create the iterator, and this is my iterator. And I'm asking it to I'm asking to, you know, I just iterated, so basically. So when I run it, so it goes over all these items. So what I can do now, I can check if it is of menu item type within this. I'm not doing it right now, but what I can do, is I can come here, when I have this, I can check if it is, if it is, what was it, vegetarian or not. So if I want to have only the vegetarian menu to be printed, I can come here and I can check if it is a menu item type, if it's an instance of menu item, then check if it is a vegetarian menu, then I print it. So this is how it works. So for some cases, I need to iterate over to check each one of the menu items. So this is then I do it. But I think this is widely used because most of the time we have a lot of, well, in most of the cases, a lot of composites. Composite pattern is widely used, well, can be used actually. It's type of a tree, that is, you know, it's a tree structure. And it is very convenient to use it like that. It's most of the times in many projects you would see that. And iterating over these is easy with this kind of a composite iterator. And just to show you another thing, so this is how it works, okay?
So the core of this pattern is implementing the iterator yourself.
No, the core of the component design pattern is just the structure of it. So it is, there's a, there is a branch and a leaf. The branch
can have also a branch.
The branch and the leaf is are coming from same supertype, but the branch has an array list of its supertype. So that is composite pattern. But the iterator is something different. It is actually not a design pattern, I believe. Iterator is not a design. I mean, iterator itself a design pattern, but composite iterator is something different. It is just a way to manipulate, you know.
Traverse.
Yeah, you need to traverse. You need to be marking that I've done with this. You know, I traversed these things and I'm moving to the next one. The very much general one for all of these is actually a graph. So, well, tree, you know, tree has some rules. For example, yeah, this is a tree, but in a tree, you cannot have this. You know, you cannot have this, or I don't know. Even you cannot have this. It has a certain structure, certain rule. But a graph, graph is probably, you know, graph. You would be thinking like graph is something like this. Well, that's a graph too, but a graph is actually in mathematics. It is yeah, there are nodes and relations. So, well, there are directional graphs. It's a big subject within math. So, but there are some implementations of graph theory. There are some libraries. It's not within Java. I don't know in C#. But there are some implementations of it. It's very flexible. You can do anything. You can point to anything. You can point to yourself. You can point to a graph. You can create hypergraphs. So it is very much flexible. So in that, traversing means that you want to iterate over a graph, which is, you know, having all of these different connections, is a different matter. With this one, it is easier because you know the structure. There's a structure, and these things are not allowed. In a graph, you can also have these things. These are cyclic, reflexive. There are some reflexive operations. These are all allowed. So you have to really follow up if you came back to here, because when you are here, if you're coming back to here, if it is pointing to here, then you have to know that I have been here before. So this is how it is.
If I need to build up a menu, I would first think to create a main component, and that's it. I would iterate many components. In order to distinguish the main menu and menu item, maybe I would add a flag or something. So what is wrong with it? So where I have to think the compose.
Let's go over what you said. You're saying is I have one class.
Yeah, because all the methods and properties are already in the main component, the base class.
Okay, let's do what you said. What you say is I will have a flag.
Yeah.
If it is true or false, I will have a.
Let's say it's a menu or it's a header. I mean.
Okay, is this menu or not? Okay.
And then I will have all the methods that you had in the main components.
Yeah, so what happens is
files.
there will be things that you're not using. Well, it is. I think the style here is important. There will be a redundancy. There will be something like there are some things. For example, if it is vegetarian or not, like the price. Vegetarian or not is not really applicable. Maybe that it can be in a menu could be vegetarian as well. But let's say the price or the description, ingredients, stuff like that are just applying to the leaf. It has nothing to do with the branch. So the branch and the leaf can have different attributes, totally different attributes. So if you combine them both, you're keeping all the attributes belonging to the two different things together. But you will be using some of them only if it's a leaf, and you will be using some of them only if it's a. So you are some of the items, some of the attributes you won't be using, right?
The real redundancy is with actually the leaf, because then the leaf will know how to add items onto itself.
Yeah, that's true as well. Yeah.
Then it will have to check back its flag each time it has to add something, which is,
But in this pattern, the leaf can still access to methods, only it throws an exception. That's only the difference. But still,
Yeah, but there is
I'm
nothing in it.
inheriting it.
But there is a different way to do it as well. We did it like that too. That is, we can call it an interface, but it really, there is nothing inside it. I mean, it is just empty. We just don't add anything inside it. It is just empty, just nothing. We could have leave it, as Janar said, we could have leave it as a abstract method. So it won't be, there won't be anything in it. It will be just abstract method. So an abstract class with some abstract, all of its methods are being abstract. It's an abstract class. So that's.
so if we leave them abstract, then we will force the. I was kind of wrong. We will force the inheriting classes to implement those methods.
Oh yeah, we would. Yes,
Yeah, yeah.
that's
So,
true. Yes. But in any case, I mean, when I'm trying to say that they are empty, so there is nothing in it, and there are some attributes that won't be, used for either the leaf or the branch. So they are leaf or branch specific attributes. I might have more complicated things like, the leaf has 10, 12, I don't know, so many attributes in it. Branch can have some different attributes in it. So when I'm having a branch, and yes, all the time you have to check if it's to avoid a leaf having leaves underneath. So that's kind of, well, I think that's, in my opinion, it's a style. Because you can do, if it is working, then you can do it. This is nice, but there are other things that you can do with this. You can have different types of leaves. You can have different types of branches with this one. You know, that's also a possibility. Because when you think about it, you know, this is my structure, and I can have different types of leaves. They are all coming from the same component, but different leaves, different classes. I can have different branches. These are branches. These are the composites. They can be all different. It gives me that kind of flexibility as well. Okay? Any more questions? No? Okay, good. We all are convinced? Okay. This is done. Let me stop here.